So my talk's the short one this week, so that's good because I'm not feeling good. So if I'm quiet, that's why I've got bad allergies. Anyway, my little talk's on Quill. And what is Quill? There's the icon for Quill, and actually, I thought it was pretty good.
It explains it really well. Talk done.
That is such an anti-icon. That's awesome.
Right. So I thought of it two ways when I first saw it. There was the painting aspect of the paintbrush, but you can also interpret it as a sword with blood dripping off of it for the painting to go through to make visualizations.
It's very environmental. Very environmental.
So anyway, Quill is just a really lightweight wrapper of Clojure on top of the processing jar. The processing is basically a very simple visualization tool that's used in the arts community for all kinds of stuff. It's used in other ones, but that's mainly how come it got started, to allow artists to create graphical visualizations and link them to MIDI instruments and other things to do interactive visualizations. And they do things like motion trackers and stuff that drive the graphics and visualizations and stuff. I'm not going to show you that because it takes a lot of equipment to hook up, and I don't want to bring all that down. Maybe next month or something, I'll bring an Arduino and twist some knobs and you can see something on the screen. But for what we want to do for the short talk, that's enough. But basically, the idea is it's simple, and there's only, go ahead.
Is it raster graphics or vector graphics?
It's raster.
Just raster.
Right. You can load SVGs in there. There's some commands that'll let you load SVG files and use them as shapes. And some of the example programs that come with it will show you that. And if you don't see them in the Quill examples, you can go over to processing.org and you can look at their example codes, and most of it is like almost a one-to-one translation because this library hasn't tried to functionalize processing to make it look like a functional wrapper. It's done it in a very few small places, really lightweight. But other than that, it's very easy to port the code.
And processing is Java?
There's two processings. There's the original one, which was written in Java. And there's a jar that you download. When you include the library dependency in your Clojure projects using MyEngine, it'll automatically pull all that stuff for you, obviously, right? But there's another version they did after the browsers came out with the Canvas class that's called processing.js. And you can use that in any browser you want to. And you can also call that from Clojure script. And it's super easy to use. This wrapper doesn't have a Clojure script equivalent right now, but you could literally go steal the code and change out the calls if you wanted to. It's pretty straightforward that way. I looked at the code and it wouldn't be that hard to do. So, as I already said, to repeat myself, these two. But basically there's one thing you do, one DSL function to find the sketch. After that, you're gonna give it a title string, a setup function, a draw function, that you can name whatever you want, and a size vector. That's just an X and a Y size, width and height. So that's what I mean about it's simple, right? It's totally nice and straightforward. So here's an example of how you define the sketch. And it's exactly the kind of Clojure you would think of, your keywords and your values. Right? Here's a setup function. Smooth tells it to smooth out the graphics. Do anti-aliasing. You can set your frame rate. You can go up to 60 or whatever, and it'll take advantage of that if the underlying graphics layer does it. And the background, you can set a color. Background 200. If you only give it one integer value or one float, it does a grayscale. If you give it 3 or 4, it'll do color with an alpha or color without an alpha. Okay. So again, here's a simple setup. Here's a simple draw function. We're going to create a stroke with a width some random width between 255. The stroke weight, a random 10. So we're gonna have a stroke potentially 255 long with a weight somewhere between 0 and 10. We're gonna fill it with some grayscale number, random 255, so we'll get a gray because we're only given one value, so it's gonna be a grayscale value. When we set up some labs, we're gonna do diameter, random 100, X and Y are 2 random locations, and then we're gonna create an ellipse at that spot. All right. So, right there, basically, that's a quill program. And there's more functions you can use. You can get the mouse, you can draw rects, you can draw ellipses and stuff. But basically, that's the whole structure of it, right? You got 2-dimensional shapes, 3D shapes, lines, vectors, those kinds of things. But that's the gist of it. I mean, it really, really is simple.
So does it open the window for you?
It opens the window. We're going to see some. We're going to do a couple of experiments real quick, and then I'm going to show you some more aggressive ones that I didn't write. I wrote some dinky, dorky ones because I'm not really a graphics guy. I was like figuring out my old trigonometry book to do stuff. But anyway, you're going to want to download this. It's like the little cheat sheet for all the quill commands. And it really is useful. It gives you what the quill name would be for the equivalent processing name, and they're all organized by type. So it's really nice to have. So I'm gonna go to the first little demo here and get rid of this error. So let me tell Light Table to fix itself here. Light Table has a bug with the Mac. If you go full screen, it doesn't like you. So anyway, here's the first little demo. Can everybody read that? Kinda. I'm not sure.
You
how
go to
get-
user behaviors.
Okay.
Go to in control space user behaviors. Right, and here, let me show you how to.
Usually I just zoom in.
Oh, if you can do that too, I was gonna say, it's LT, you know, in your editor, you see your editor? So add a LT objects font settings. I know there should be like yeah. Yeah, LT obj style / font settings. And then any font family, or just yeah. It does have good helpers, and then a size. So, you know, I use 16. You got 18, 20, 23, 32, 22, 33. There you go.
Thanks. Okay. So there we go. Anyway, in this one we do a simple setup. The background again is a gray value here for 200. We set the frame rate to 30, and then. In this case, originally it was doing some simple gray circles like I showed you the code first, but I didn't like that. I wanted color circles. So I came down here and I told the fill statement to create a color with 4 random 255s. Right? And then the sketch is basically the same thing. And you can name the setup and the draw function anything you want as long as you make that setting correct. So then to run it, you just do your normal eval thing. It connects in REPL, loads of dependencies. Then I'll show you as soon as it does that. It'll pop up a window. Now it uses AWT underneath as the graphics layer, or Java 2E actually is more correct. There is a setting you can give it down here for the renderer type. And you can tell it to use OpenGL or processing 3D objects. But there's a couple of bugs on those. Anyway, you should be able to see now the colors got transparency in there and stuff like that, and the color sizes are random and stuff. So that one little program does that.
It's scaling it, or did it resize it?
No, that resized the drawing area.
So your app knows that it.
Yeah.
Okay.
Yeah, it automatically adjusts the
Looks like it
drawing area.
restarts whenever you resize.
Yeah, it does. Right. Restarts the setup, basically. Okay. So that's the simplest kind of thing with a simple color. Now, I can go in here live and I can change one of these things to be like 20. And then, like we would expect out of Clojure, because it's a random language that just keeps running. Right? Now the difference is, I actually hit Command Shift Return and cause it reevaluate the whole file. And that's not what we want. That's what most people would expect from a DOM language. Right? But if I just come down here and I do Command Return, I'm editing live in that window. So I can do my graphics programming interactively while I'm in the REPL. Really kind of cool. If you're an artist, that's even fine. And processing, regular processing doesn't have that. Even if you use processing.js, you don't have that. So this is a small advance over what other people do. Right. So that's demo 1.
So what is the exception? What was the exception?
Runtime exception, unable to resolve a symbol. I don't know why. It wasn't bugging me earlier, so I was like, forget you. I've got code to write. So here's another one. This one does something kind of similar, but this one's going to use one of the little 3D objects. And I haven't played around with this much, so it's not exactly a pretty 3D thing, but it does do the 3D stuff. And since I closed the whole window last time, it's got to relink the dependencies and rerun AWT and all that stuff. So it's doing that now. And those are actually 3D spheres. I'm not stroking all the lines, but you can see them in there, all the facets. And you can control some of that stuff, how dense the thing is. And you can control lights and spotlights and stuff like that. It lets you do some of that. And there's a box. Like we can go in here and
So that seems reasonably slow, or unreasonably slow. Is that can't be a Clojure thing? It has to be a processing library.
Yeah, it's the processing library. Yeah. So I'm going to go here and I have to give it 2 arguments. And then, I think that's right. Can't remember how many arguments box takes.
Does Control D work on the box? Or the backstreet work?
I'm not sure, to be honest with you. No, it's not pulling anything. Sorry.
That's because you're still trying to connect, I think. We can do it.
Okay, let's kill that guy. I had this
Box
with light table.
size or width, height, depth.
Okay, cool. So I had that with light tables. Sometimes I got it into a state where it's up there spinning at the bottom, and so I just had to quit it and just start over.
Same here.
So let me go back in, and I'll try the width, height, size thing that Norman said for that demo real quick.
I'm trying to figure out why reloading the draw function would work here, because you're not passing draw as a var, you're passing it as a function. So when you reset the function, when you reevaluate the var, it shouldn't actually update. So I'm kind of curious what was going on there.
Well, we reevaluated the function, right?
Right, but
So-
but you're passing the function value, not the.
Yeah, but remember the library underneath made.
That's what I'm trying to figure out what it was doing, because you're not.
Yeah, I'm not sure. to be honest with you. I'm
No,
just
no,
a user.
I didn't think you would care or bother to look at something, but I'm just
No.
curious.
That's for people who write libraries. I'm a user. I got better things to do.
If anybody happens to know, I'd be curious.
Anyway, so that one's still doing a sphere. Let me close that. And I made it draw a box in setup, so that was stupid. So let me copy it here. Bring it down here. Okay, so.
It's allergies.
Yeah.
While you're going, I found that it's in the def applet macro. It actually checks if it's a symbol and rewrites the symbol as a var, so that specifically so that you can do what you did and confuse people who are.
Def sketch does the same thing.
What?
Def sketch does the same thing.
Yeah, def sketch calls def applet. So.
Okay, so for people who overthink things.
For the one person in the room who actually cares, I'm talking to myself.
I only care when it breaks. Like it did,
But
but.
it's just when something has a behavior that's out of the ordinary, you're like, why?
Yeah.
Wait, what's going
So
on?
there we go. We got the initial sphere, and then we got all the boxes drawn. Now, one of the things that's weird is there's perspective in here too. So when I redo this, you'll see the perspective of the boxes change. But you can play with the camera too. That's another thing it has. It has a camera. But I'm really not a 3D guy, or 2D graphics are my speed. So, let me show you another one.
Sure.
So this one,
Clojure. When you're
This one is-
here, you want to see it all.
yeah, exactly. This one's a poor man's drawing program. So if you're an artist and you're thinking, I just want to do something weird, this is about as simple as you can get. So I load up an image of, well, it was supposed to be loaded up. Let's see why it's not. Oh, there it is. Okay. Go away. Let's give it one more chance. It might just be because the image is so big. It works perfect on my machine.
That your machine. You're playing with TV and sharp TVs.
Yeah. Anyway, yeah. So here I'm moving the mouse and it's leaving a trail. I don't know why it's trailing the black line there. Because that's commented out. Let me try one more thing.
Maybe the background is default black, default zero.
No, it was working just fine, literally, with no changes on the machine. I tested all these before I came. That's why.
Did you run them from Light Table?
Yeah, that's what I was doing.
Because I
all
didn't
in.
know if the file name where you started from was.
Yeah, no, I did them all in Light Table because I was paranoid that it wasn't going to work.
Only has justified.
Yes, it was. Okay. Let's try one more time, and then I'll give up on this one if it doesn't work. You saw the map flash up there briefly a second ago. Now it's drawing white. Anyway, there's this huge ass map image that was lying there, and these were red. And as you press the mouse down, it leaves a trail. Has to be something with the
Why
interaction
is
between
it
the
so?
two.
Why is it so?
That's
rare?
because of the sample rate. Again, processing is it's not the speediest because it's built on top of the Java AWT stuff, and then they patch in different renderers. So it's got its own little quirks. Like anybody who wants to do really fast graphics with it, will use the OpenGL drop-down layer. So anyway, if you want to see the actual map on this one, just see me afterwards. I'm not sure why it's not pulling up there because it was doing just fine like 10 minutes ago. So now I'm going to go down here and show you. There's this nice book from O'Reilly called Visualizing Data that uses processing to do all kinds of data visualization. And this particular project, somebody took all of those visualizations out of that book and created Quill equivalent something, right? So there's some pretty nice ones. In this case, we load up some data first, and it's connecting, retrieving its dependencies, all the stuff that a table takes a long time to do. Closer. Oh, thank God. Okay, so now we're gonna run one of these, and here's our first visualization. We get a nice plot of what turned out to be the coffee data. That's what it was. In case you didn't see the data set here, it was milk, tea, and coffee data. Right. So much like you could use God, it popped out of my head. Incubator. You could do the same kind of thing here. Let's do another one. This one's bigger. This one's a nicer plot.
Yay.
Right.
What happens when you resize?
On this one, nothing.
Need to fix that by not allowing resize.
Oh, good save.
Jill, I haven't been drinking yet.
Yeah, there you go. So here's another one. And they get progressively more interesting. I'm going to show you the final one on this one. Nice line chart, right? So the thing with this is if you add in the mouse tracking, you can have it pop the number. And the thing to notice on this particular one is the program is still relatively short for what you do. Create a column, add them, get the current column that you're calculating. You do some basic depths for what year you're on, the plot, X and Y and all that. But the basic program is still the setup at the top there. Some draws for the plot area, the title, the axes, and then the draw function that calls some helpers. So it's really not that much more complicated. And this one's basically one page of code. Okay? So we're done with that one. Let me close these off, and then I've got two more to show you, and that'll be done. And we can get to the meat talk. Here's some more data for this one. Chose the wrong one, so we'll see. This one might error out.
So this is network traffic that's going on right now, giving you a bunch of stuff.
Yeah, earlier the Major League Baseball site had changed their URL, so let's see if this one's going to work or not. I got an error. Try to fix it.
Hated when they changed the URL.
I hear ya.
Temple was in town today. You could go wrap them on their knuckle.
Yeah,
The URL is for
I
everyone.
wish. Okay, so here's the visualization. This is actual real baseball data from, I can't remember what season it is, but anyway, in the book, he talks about the wins and losses relative to salary caps. I must have scrolled. Anyway, there it goes. It's redrawn, kind of weird. Come on, redraw. Here's another one. Oh, he's having a redraw problem too. But anyway, the idea is the wins and losses relative to your salary cap and who ranks where and whether the salary cap and paying more for players matter. Not sure what the bug there is, but we'll come back to that. I'm wondering if some of it's because of the video.
It's all my fault.
Yeah, that's it. We'll blame Andrew.
Go for it. I'm just a four-year even. I can go off for
It's a heckler.
that too.
It's good to have a heckler. So here's another one.
Don't ask for Python if they really don't like that I have.
I actually don't mind. It's more. So this one's actually related
We're already
to
sending emails about you.
zip codes. And this one here, they take the zip code data and stuff and plot it, and you get to see basically the zip code data. Turns out to show us the shape of our country. So that was kind of pretty cool. And then there's another one, another variant of that. Where you can type 78 and it highlights the zip codes with that, those start two numbers, right? So if you type 212, you get up to there. This little tiny spot, right? So it's a nice little visualization.
Almost like that bitmask on geographic data.
Yeah, exactly.
It's pretty cool, actually.
So you can start with that
Yeah,
or
I'd love to.
98.
Oh, I would love to.
There's Oregon and Washington. So it's kind of cool. And this particular program that does that is the same deal. It's like not even a whole page, right? And then the data was another page, right? The other thing I didn't show you on here, but doesn't really matter. And that's kind of all the demos I have to show you right now. But basically, for a lot of the stuff, you can download processing support, downloading XML data, JSON data, all that straight from URLs. And you can use all your Clojure functions inside there to massage the data before you use this to visualize it, right? And again, same thing with Clojure script if you use processing.js. So in addition to Incubator, this is a great little tool to visualize data. And actually, I didn't show you one of the demos. There's another demo that showed some more mouse stuff. Right? But if you want to see the map, I want to actually show the map correctly. Talk to me after. I'm pretty sure it's the video talking about it before. There's the map flash for a second. Any questions? No? That boring? Okay. Thanks for calling. Next we have
How big was the impact of the salary cap?
$1.
$1.
No, if you're actually a data scientist, you may or may not have other tools at your disposal. The big deal here is the turnaround time and having the limited palette of functions that you can choose from kind of drives you to do other kind of creative things. But the focus there is on, you do your initial setup, which is read your data, and then you do the drawing and interacting with the data very simply, right? So it keeps you incredibly focused on only doing the one thing. And I think that's a nice thing for the library. As far as how it affects us day to day, probably not a lot. We're not artists. We're not the target market per se. But by that same token, those visualizations I just showed you with the baseball salary caps and stuff, some of those things have ended up in like USA Today and stuff like that. So they haven't been interactive versions, but they've been the static ones. And then on the website, they've actually been rendered in processing.js so that people do interact. So one of the things I see as potential is for this, if this library is working on 2.0 version, you can do the same thing with the same API set and have it use Java FX libraries underneath, which are all hardware accelerated and much, much faster as the rendering layer. So I use a simple API. And that's one of the things I'm hoping they'll do. Anyway, Andrew Donahoe is going to talk to us about Lambda architecture, which I think is an architecture that calls back on itself. Anyway.
No, it's immutable. That's, he calls it because of the immutability. So thank you, everyone, for having me as a well-known Clojure voyeur. Okay, I like to watch, but I don't actually write Clojure. Okay, I do a lot of analysis, and recently I've been doing a lot of big data analysis. And one of your leading lights in your community, a guy named Nathan Martz, okay, who created Storm and Cascalog and several other things that are Clojure based, has been promoting this idea of a Lambda architecture. And I've been using many of his ideas in designing systems that I use. Now, my client doesn't want me to talk about his stuff, so I'm going to talk about what I do for myself. And then we're going to go through Nathan's talk, because Norman and Sam thought it was worthwhile to the rest of this community for me to repeat giving this talk. I took Nathan's slides and gave this talk to another group. They really liked it, so they wanted me to come give it to you guys. So I hope you all agree that it's a good thing. So this is a product that I'm building. Just started showing it to the world 3 days ago. As some of you know, I have a Twitter analysis tool called Retriever. This is called Image Retriever. And what you don't see on Image Retriever is porn. I have somehow become an internet scold. And I have almost 1 billion tweets at home, and they take up a lot of space. And I've had to embrace the mechanics of big data analysis to actually go through these tweets and actually find the malefactors, people I call Hesters after Hester Prem in the start of the letter. I go find the Hesters and go find a lot of really obscure terms. And then, when you've got 1 billion tweets of something, some signal starts coming out of the noise, right? And so I found a lot of things. And so I use this to actually keep the screen clean, okay? And that actually is surprisingly difficult, particularly on big tags like South by, or Oscars, or Grammys, or Super Bowl, all right? Because these people, there are 2 communities that jump on those big tags. There's a spammer community, and then there's the porn community.
And this is South by Southwest tag?
South by tags, yes. These are South by tags. As well as Seth by South by, right, for Seth Myers. Okay. So the point is that I'm using big data analysis techniques, and I can talk to you in depth about the kinds of things that I'm doing, to actually build these anti-porn filters that this little iOS app uses. Okay. It itself isn't doing anything with Clojure. It uses the results of the Lambda architecture, which is inspired by a lot of the ideas in Clojure that Nathan Martz embraced. So now let's jump into the talk. I really like giving digressive talks, so you should feel comfortable stopping me, asking questions, okay? And heckling, I like heckling as a DH, designated heckler, as you've heard, okay? Or branded heckler or scarlet letter, H is now on my chest all the time. But I very much want this to be a dialogue, because this isn't my talk, this is Nathan's talk. I've now given it a couple times. And I have some views on some of the things he says also. Okay, so one of the big things he is about, after having had his turn before the mast at Twitter, where he was in charge of implementing their Storm-based architecture to deal with all of their real-time processing, okay? That there's huge complexity in big data, all right? And it runs away, and the question is, how can you architecturally harness that so that you don't inundate yourself, all right? So you're going to talk about common sources of complexity in data systems and design a fundamentally better data system. And that is his goal, is to find something better all right? And it will embrace concepts of mutability and immutability, how to use them right. So these are very much Clojure kind of concepts, okay? So to him, a data system, you know, is all architects do when they leave their big money-making thing. They start talking, you know, very high level to try to justify whatever, right? So these foils have a bit of that, okay? Very high level view. So manage storage and querying of data, okay? Okay. Lifetime measured in years, okay? And this I have to agree with. I mean, the billion tweets I've been collecting since September. I'm probably going to keep them for many, many years because they've been a foundation of building strong filters. Signals pop up over time. And so lifetime is measured in years, and almost anything that you can start to do, keep around, okay? This is extremely important because applications do evolve. But because you have a data system that may evolve in certain different ways, your production people may be evolving differently at a different rate than your development people. And so you have to manage the difference of versioning between those two worlds, okay? How can you handle that easily? Normally we talk about doing migrations and things like that, and that's a really painful process when you're dealing with terabytes of data. Right. I was at South by, and I'm looking at, okay, you know, I could build a stack of drives, or looking at buying a 20 terabyte RAID system. 20 terabyte RAID system. So I can have 2 RAID 0 arrays, one for my indices and one for my data. Okay. It boggles my mind that I need to buy something like that. Oh, and it's also only $1,700. That also boggles my mind. Okay. But the concept that I actually am going to need a pair of RAID zeros on a Thunderbolt interface to just sort of pound data. And it's at that my current drive, the single 4 terabyte drive, that I pound, I'm only getting 100 megabytes a second into the drive. What do you mean you're only getting 100 megabytes a second? When you're really doing stuff and you're randomly sorting, I mean, you need every ounce. And if you have to then version your database, and it's big data, you are doomed. You cannot plan to version your data. You cannot plan to ever migrate your data if it's big. Just not going to do it. Right? You can't afford to do it. So you have to have a system that embraces immutability. Once that data hits the disk, it's stuck. It doesn't leave, it doesn't change. That's one of the big things that happen. As soon as you have to start managing every version and your data is large. Does that make sense? Okay. Has anybody else started to have these problems in their day-to-day work?
We have a lot of deniers.
Yeah. Yes.
We don't think that
I've seen it with data that isn't even that large. It's just for land.
Right. So, if you guys want me to come in and give this talk, I can do that. You know, then you can have plausible deniability. All right, this guy's just a porn filter king. You know, what the fuck does he? Excuse my language. Okay, what does he know? You know, he's probably not a very hard problem.
It's just data, right?
Right, it's just data, and it's just people trying to get around every filter you might throw at them. Okay. And every hardware failure. Hardware fails, you want to be able to recover from it, which means you have the partitioning problem. All right, so does everybody know about the CAP theorem? Okay, so there is the simplistic view of the CAP theorem, all right, that pick two, consistency, availability, and partitionability. Pick two out of those three, okay? In practice, that's too rigid a view of what the CAP theorem actually says. And if you go talk to Eric Brewer, he has recently revised his view, that it is not as rigid. I'm also going to posit here, Nathan doesn't really say it in his foils, but time is an extremely important part of your data system. So when something is partitioned is really important. And if you have a system where you have immutable data, the question of consistency, availability, and partitionability is dramatically changed because that data hits the disk, maybe it hits it in three disks and then all of a sudden, partitionability, availability, everything's just done if you can recreate everything from that immutable source. So a whole bunch of things change, and so everybody's used to thinking of cap there and pick two, and you're doomed regardless. It's like entropy, right? But it's not the way it really is going to be.
But that gradient is temporal. So like, when is it available, or when is it? What you were just alluding to is when it's actually partitioned, or when it's and with the level of consistency is when it comes to that point of consistency.
Right, and so we will be talking about these kinds of questions throughout the discussion of the Lambda architecture, all right? But an important part of understanding what it means to be managing big data is about to be managing when this data sticks to disk and what you can do to it. And if you believe that your data hits the disk and doesn't change, is immutable, then a whole host of different things start happening for you in the rest of your data system that are good.
Yeah, that's the same thing Hickey's
Right.
got behind Atomic.
Right.
For
And
temporal.
it's a fundamental piece of Atomic, yes. I'm not familiar personally with Atomic because that would involve me writing Clojure. And I am a voyeur, so. But I've read enough about it that I believe I can say that.
But there are bindings for other language, for Java, Python, other things.
Okay, I'll take a look.
You're not forced into it.
Not for, well, you know, again, I like to watch. It's very simple.
We saw the picture.
Saw the picture, you betcha. And this is very important too. We as programmers don't really believe we ever make mistakes, even though we have a lot of evidence that we all make mistakes early and often. Not just in our career, for all our career. We're always making mistakes. And that data systems, if you have mutability built into your data system and you screw up, you've screwed up a lot of things. That could cost you millions and millions of dollars to repair, et cetera. So mutability, for all of these reasons, and this is probably the most frequent one, human mistake, and we all like to talk about hardware reliabilities. It's really our human mistakes that are really the biggest threat to our data systems, okay? So, we have to look at these sources of complexity. Lack of human fault tolerance, all right? He thinks this is important, that it's easy for humans to make mistakes. If your system isn't robust against the presence of those mistakes, you're screwed. Mutability and immutability is the difference here. You have an immutable base, then you have fault tolerance. You can recover, okay? Conflation of data and queries, okay? You look at many of the NoSQL databases, one of the things you start seeing is, it's not that it's NoSQL, it's that the querying systems are frequently so separated from the data, rigorous. For example, the database I use, Couchbase and CouchDB, CouchDB is my archive system, it has a complete view indexing system that's written in JavaScript that runs totally separately from the stuff that stuffs the stuff to disk. And it's always running a post-processing step only after things have been safely written in an atomic fashion to the disk. All right, so in other words, you can't even query data in Couchbase or CouchDB with your indexing system until after it's already safely partitioned, right? And that's called eventual consistency and has several other things about it. But part of the virtue is that that document is written and done. It's immutable before you can actually see it in the queries. And so their architecture really keeps you from conflating data and queries, okay? And one of the things is schemas are done wrong, right? NoSQL seems to have, a lot of people are all about get to abandon schemas. Well, you know, I work on the Twitter data source, data structures, and it's all JSON, and all of you all know JSON. You say, oh, there's no schema there. No, there is an extremely rigid schema. Every tweet is the same. 1.5 kilobytes, it has a whole bunch of standard fields that are done this way. There is a schema. It just happens to be defined in a flexible transmission structure called JSON that reflects very nicely into dictionaries, maps, hashes, pick your language term. Right? But there is still definite strict schema, and you have a definitely strict way your code can access it. Now, there can be lots of other things. The schema can mutate in ways, and it can have an additive addition painlessly, okay, which gives you a huge amount of flexibility. So that tweets from 3 years ago don't have certain things in them, like before Twitter started putting cache tags in the tweets. There's an entity now called symbols, which are basically hashtag is a $ followed by a ticker symbol. AAPL, for example, or IBM, or what have you, or T for AT&T. Right? Those are all $T is AT&T. Right? That wasn't in tweets 3 years ago. But everything else in that tweet, I can read today. So there's definitely a strict schema, and they've been focused very much on being additive on it. Most people, you know, worry about the schema, and here I am in a world of dynamic languages and Clojure, and you know, people frequently rail about type. Type is not necessarily bad, and in some sense, type has helped save Twitter's growth because they use JVM-based languages. They use the name of the
Scala.
Not Scala. No, the thing that it's an Apache project that's used just for marshalling and unmarshalling data. Whatever, it is a standard Apache project. Most people who are big JVM people and servers know what it is, but it's, anyway. So let's get back to fault tolerance, okay? Bugs will be deployed to production. Operational mistakes are made. Humans are part of the system, okay? They are fault creating parts of your system. They will create faults, they always will create faults. Even rock star god computers, they will sometimes throw up the oops sign. It does happen. Your architecture, particularly when your data gets large, has to be resilient against this. If you think about all of the things that are happening in hackers when they infiltrate systems, one of the biggest things that hackers try to do is erase logs in other aspects of your system. If your data systems are designed such that they never erase things, and with 20 terabytes only costing you $1,600, $1,700, why are we erasing anything? Particularly if it's mission critical or business critical data, okay? Then we need to embrace the idea of immutability in our data so that these problems that we know are going to happen don't permanently fix it.
So I'm confused what you mean by human. Give me an, I was gonna say give me an example of a human error, but I see your next slide here.
Okay. Deploy a bug that increments counters by 2 instead of by 1. Accidentally delete data. Accidental DOS on important internal services. Those happen all the time, right? Right. We've seen people take down their devices because their internal servers because they start updating the data too much. Okay, and just crushes the poor database, right? Okay. Worse is data loss or data corruption. So, if your data was immutable, you're never going to lose or corrupt it. You can fix what went wrong. That's really important. So, immutability lets you have this property. Okay. So, mutability, the U and D in CRUD. Okay, mutable systems updates the current state of the world. Apparently lack human fault tolerance. easy to corrupt or lose data. Right? This is near and dear to the hearts of Clojure users, right? Immutable data structures are what lets you go fast, or what lets you go parallel, what lets you make asynchronous I/O calls. A whole bunch of things happen because you have immutability in your core data structures. It makes it easier for you to do things than the JVM, the Java people who use the exact same JVM as you do, right? You know, that is a key thing, is that your language has embraced immutability. The environment I use most in my personal stuff is iOS, and in its object hierarchy, immutable objects are higher in the hierarchy than mutable objects. So you're mostly dealing with immutable things. And occasionally you make them, no, you're mostly dealing with immutable things, and occasionally you'll make them mutable. Here's an example. That has allowed the Apple environment to embrace their asynchronous model called Grand Central Dispatch, where they're throwing Clojures on queues and get dramatic performance improvements. So despite the fact that all these devices, this has 2 cores, and it's very easy for you to exploit the 2 cores because I have immutable data structures. Whereas in environments like Python, and I believe the same is true of Ruby, because mutability is high in the inheritance hierarchy, it's harder to actually separate things so that things can be independent. Okay. Immutable systems capture historical records of events. Events happen in a particular time, and it's always true. Okay. So what this means is that systems that depend upon immutability are logging systems. They're event-based systems. They are additive. They show the history, and you can basically recreate your data from any point because you keep track of all of the transformations. Which means you can see where the error happened, and you can roll up to that point and then not do the error. That's always a good thing. Right. So if you were really buying into the idea that immutable systems let you recover, then you're also buying into the idea that they transform in an additive fashion. They are logging-based systems. You look.
You're just describing a lot of the topic. I mean, a lot of the topic is based upon creating these structures for exactly what you're talking about.
Good. Okay.
So with backends, within backends availability, in fact, your disk writing is what you're writing to disk is actually pluggable between other technologies. I think the other modules are like, one of them might be even couch actually.
Very well could be. So the point is that immutability, one of the core concepts of Clojure, has strong implications for data bases, all right? And that for some of the same reasons that you get benefits of it in Clojure, you can get benefits from it in your large data source, in your large database. In fact, I think the benefit is even manyfold, because once you start getting into data stores that are 2, 4, 10 terabytes in size, you can't even back these things up. Okay, it starts to become prohibitively expensive. So you better start having distributed partition systems that are inherent backups, because you're not copying this data anywhere except incrementally the way it started, and you're not going to be able to really get it off onto other systems, right? Because you're always going to be adding to it.
So when you said always true there, I get that you're saying more than just you can't delete it, but you're not saying that you couldn't have something later that provides new data or something
Right.
there. Like, what is that implying? I mean, I feel like I'm missing something.
Well, it implies an additive view model. Okay, so in other words, queries are things that look into it. That's different than the data system. And so the query can actually resolve the history, the journal, to get a different view without you losing data. Does that make sense?
Right, yeah, I just thought immutable. Yeah, it may just be, I was just trying to think if it was trying to imply something more than.
No, it's not trying to imply anything more than what you think it is.
Okay.
All right, it's very simple and straightforward. It's not trying to be complex. It's not trying to be subtle. It's trying to say, once it hits the disk, it's done. It does not change once it's on the disk.
Life cycle over.
Right, we are done.
So my understanding was, or what Sandra talks about is, for example, that you never, once you write the, you just have a version of the data, and you never update that data. You just write a new version of that record.
Yep.
Is that what, am I understanding that correctly?
I believe that's the case. Yes. I'm not a Cassandra person at all.
No, but I mean the same, you're talking about the same thing.
Well,
You never overwrite the data.
They
You
can
just-
update,
you
they
don't
just don't
up-
recommend. That's not an architectural pattern that they recommend to update. They suggest that you should just keep writing. And Cassandra itself is optimized for heavy writes, sparse reads.
So, capturing change with immutable data model. Sally moves from Philadelphia to New York. That causes problems. Immutable data, this is how it changes. Everything gets a timestamp. Timestamps are very important. First place I gave this talk is another meetup called the Distributed Systems Enthusiast Meetup. And fundamentally, we had a large arm wrestling discussion about CAP when I gave this talk. And it was terribly much fun, okay? But after that talk, the next talk was given the next month by Ray from Black Locust. It's about the CTO of LinkedIn has written this really nice long blog post about log structured databases and why your systems really need to be structured around the idea of a database transaction. And it's the basic same idea. I can tell you that on my machine of choice, iOS, they recently updated the data structures to use SQLite's write access logging. The performance dramatically improved because logs are built until they are then merged to the data, and the database is merged in one swell hoop, and it runs much faster. Pending, and then occasionally there's a merge. The merge doesn't have to be that strong. It doesn't have to be that expensive because it's like one big bulk thing. So lots of stuff happens and then we're done. And it tends to run very well. Immutability, just like in Clojure, greatly restricts you. It's a discipline, okay? Except Clojure imposes the discipline. It's part of the architecture, all right? Databases rarely impose it. For example, Couchbase and CouchDB both will update. They do it basically in an append-only mechanism, but as soon as you start to run a compaction load, then those old versions are gone. Right? So both of those databases are not pure immutable. You can actually get rid of things by if you use them poorly. Datomic and Cassandra, it sounds like it's harder to do that. And everything is a performance balance issue. Okay. Vastly more human fault tolerant. He's really into the human fault tolerance thing. Clearly he's been burned by colleagues. So, okay. Yeah, this is clearly a nervous twitch from his. Okay, so other benefits, it's fundamentally simpler. It's create instead of CRUD, only write operations appending, which means you can build tail write append-only databases, which in environments like Couch, which I know is basically everything gets written and then the final 4K word is written. And if you know that that's written, you can read it back, then you know everything up to that point is correct. Or you can go back and find the old one and everything was correct before that. So fundamentally, databases can make really, really strong ACID guarantees. If, for example, in Couchbase's case, they write ACID documents. And I can tell you that it's a hell of a lot more likely that their claims of ACID are true than any relational database's claim of ACID. Because they put some constraints on you that says everything is in one write. And we know it either completed or it didn't. Right? And when you have your data scattered over a dozen tables, you know, that's a very, very complex system that it's not at all clear that the database vendor will have actually tested to make sure that something is ACID. And so you start to design your documents differently. So if you're in a world with ACID documents that are ACID written, you probably put all the things that are in the state transition in that one document, you write it, and then maybe you do some other stuff. But if you basically incorporate your state transitions in ACID documents, you know exactly what changed. Okay. And since disks are cheaper, and remember that the relational model was in many ways about minimizing disk storage as well as seek times. Okay. And we're in a world of SSDs and RAID zeros and a whole host of other things. Many of the assumptions around relational databases are maybe not as important as they used to be. One of the most important things to recognize about the advent of things like Moore's Law is that stuff that used to be expensive, after 3, 4, 5 exponential doublings, is no longer expensive. And if you were optimizing for that, you are now wasting your time. And so when machines like this have 32 gigabytes in them, I don't worry about the size of data. Okay. When we have 20 terabyte boxes that are like, literally it's like this, 20 terabytes, you know, it feels very good. Okay. So, only write operations, pending new. Easy to implement on top of distributed file systems. Everybody knows that you do not put your relational database on a distributed file system. Okay. Well, if you are a append-only database, then you can actually know that it actually made it all the way over there. The semantics of the network file systems actually work. So if you want to use some of these fancy global file systems like the GFS that Red Hat uses or some of the other things, you can actually do it here. Whereas almost every other database technology you might dream of using will never be reliable enough. Whereas this actual model is reliable enough because you know when you can fail or not in a very clear fashion. One of the most important things you can know about security, for example, is it's not so important that your code, it is important that your code is secure, but what's most important is that you know when your security is failing. This is what's so bad about the Apple go to fail, right? No one knew. So 600 million plus devices were exposed to our friends at NSA. See, I'm wearing my EFF pin in honor of Mr. Snowden. Snowden at South by Southwest. 600 million devices were exposed for 18 or more months. Okay. Now, no one will say whether that command V of the paste go to fail was an honest mistake or a super patriot who works for Apple did it. No one is saying it. And I know plenty of security people, and you ask this question and they stop talking. This is clearly a very, very sensitive issue inside the company. But regardless, they got pwned hard. They got pwned hard. And they didn't know it. And so in terms of system design, they failed. All right. Now it turns out it's ridiculous. If they just turned on some warnings, they didn't even need static analysis. There were built-in warnings in both GCC and in client that would have identified this. Okay. It's ridiculous that this got. It is just profoundly ridiculous.
Just a side note on that, did they not have this in a revision control system where they can go back and see who made the change?
They are not going to talk about it.
Oh, okay.
Okay, they are not going to talk about it.
I mean, because
Yes, it is.
Even CVS or Perfor, I mean, what?
They are not, oh, of course it is, but they are not going to talk about
So
it.
somebody knows.
Oh, yes, they know. Oh, yes, they
Because I look at this as a project, I mean, what, it's not on somebody's disk that they just made a change and it magically showed up.
No, they know who did it, almost certainly, and if it was a mistake, we've had that discussion.
Steve Jobs rose from the dead to.
If it wasn't a mistake, then it's probably
How long could it have been in there? I mean, he could have still been alive.
it's been there since version 6 of the OS, so he was dying just before it went in. Or, yeah, he died just after it went in. So, regardless, I myself try not to go down the paranoia level, but then we've read all the things that Mr. Snowden found out. And, I'm not above believing that, an Apple employee is a super patriot and do something that NSA asked him. Okay, so, but let's just accept that it was an error. That's the easy non-tinfoil hat notice. No tinfoil. Okay, no tinfoil, okay. All right, and I wear this hat a lot. Okay, so it's just plain strong. Okay. All right, immutability. He wants to encourage you to follow the patron saint of Clojure. Okay. Everything I've read that Rich has written or seen on videos, I agree. Okay, now this is the big one. This is one of the big ones. It's conflation of data and queries. In the database I use, Couch and Couchbase, CouchDB and Couchbase. You can't query anything until the index is done. And you can't actually, all you have about a document is a key to get a value, right? It's basically the JSON document is the value. You have a key and you can get it, okay? That's all you have until the queries happen. And so it forces a very strong separation between data and query. Now, people say, oh, in relational databases, oh, you don't need to have all these pre-made indices, et cetera. And that's not even close to true. You can't have a database of any rational size and not have indexes into it and actually expect to use it. All right, you just can't do it. People claim they can, they don't put that in production. All right. So fundamentally, there is actually little difference between a relational database and a NoSQL database in this context that you can't query any of them once they get to any kind of modest size without indices. So indices are a query time phenomenon, all right? And so conflating data and queries is really important. It's all tied up with indices, okay? Also, there's the issue of normalization, okay? Normalizing your schema is about minimizing your storage. So that you store something in exactly one place and everybody gets it at the same place. And if you're willing to mutate your data, that's extremely important. All right, because once you start denormalizing data and it can mutate at different rates, bugs creep in. If you have an immutable storage strategy, you don't worry about normalization. You just stuff it there and then you resolve it when you need to during the query process. Okay? So joins are too expensive, denormalize. Okay. That's what you'd expect. Okay. The way data is modeled, stored, and queried is complected. It's complex. Okay. His architecture, the Lambda architecture, is about disassociating modeling, storing, and querying. That is the core goal, is to split those so that these properties we're talking about start to emerge. Okay? Okay. Schemas have a bad rap. Absolutely true. Okay. Schemas are frequently hard to change, they get in the way, add development overhead, require annoying configuration. All of these things are true. All of these things are not characteristics of schemas. They're not characteristics of type. They're characteristic of data systems that manage schemas poorly. As I said, looking at the Twitter data stream, there is a very stiff schema there. But because it maps into dictionaries and is a very simple data structure of a very limited number of types, we all regard it generally as a nice, easy to use, relatively pain-free environment. And it is. It's loosely typed, but still typed. A number is a number, or a Boolean, and or it might be null. All of these things are true about it, okay? I know, use a schemaless database. Overreaction. Actually, I believe there are no schemaless databases. If you're going to query on anything, there is a schema that you have to depend upon. There is a structure there, or you will never be able to query it. That's why we all go through an ETL process, right? When we build our database. Schemas provide value. Part of the value they provide is that you can then start to factor your code into access patterns. And you can start to exploit these abstractions stiffly. So if you think of schema and abstraction, they are basically one and the same in my book. They let you view your data carefully. So you can see where this is going, right? You know, if I'm going to talk about an abstraction and make it stiff, and then I have all of this log-based immutable data, that abstraction is going to end up being responsible for resolving that temporal issue. Okay. So with Clojure, you've got a language that does types right? It does schemas right. It does abstractions awesomely well. It's total down with the immutability thing, right? You know, life is hunky-dory, life is good. So you can't complain about doing schemas because you're all about immutable abstractions, right? So you really are doing schemas. All right, so he goes into this discussion of functions data unit. How are we doing time?
8:30.
8:30? Okay. Okay, we got a lot to do. I'll speed up. They're going to kick us out at 9, right?
No, I'm sure tonight they'll be here a while. You know, with all the events.
Can we confirm that?
Yeah, the 9. Yeah, we can go past 9, but not past 9:30 or so.
Okay, I don't want to be rude to them because it's
Oh, no,
always
no, no,
so
they're-
kind.
they're-
They're always so kind to have.
Yeah, no, they've got more events going on tonight, so.
Okay, as long as Nicole's on board with that. I just don't want to be rude because they are so nice. Right. Oh, losing my audience. Thank you for coming. Thank you for coming.
Yeah, and if we do run long and anybody has to go, we won't,
I
we won't
take
make
it
fun of you.
Up until then. Thank you for finding Thank you for finding out. All right, so a data system to him is a function on a data unit. Basically, it's you're going to invoke something to get a response. All right. Now again, like I said, CTOs lead these fancy gigs where they get all this stuff. They start talking in abstractions the way they always wanted to. With no one. But this function on the data says whether the data is valid or not. This is extremely useful. So validation is very important as part of the ETL process to make sure your data structures are good. Okay. Values of schemas. It's structural integrity, guarantees on what can and can't be stored, prevents corruption. Okay. This is motherhood and apple pie for you guys. Right? This is exactly what immutable data structures and trees did for you guys. Right? So this is where you are already. I don't know about you, but I really don't like finding runtime exceptions on my data structures. I really don't like it. Okay, so when I'm running through data structures and all of a sudden I start getting exceptions because things are there and the systems are crashing, etc. I really would prefer on these data systems to be able to have some strong types to actually keep me from writing stupid code. Because I write stupid code all the time, right? And I can corrupt stuff. That's part of the human faults. So type can help me. That's why in the Python code I use, I'm one of the few to the crowd that use Python 3 as well as use the abstract type system. Because types are my friend. And they actually have done a decent job in Python in that the types are annotations, they're not required. So they just help the IDE. It doesn't actually change execution at all. Python will still go and do all the random stuff that it's on. Problem with data systems is corruption can happen and you may not see it for years. And you may have been doing it in a corrupt way for a long time. How many people read your backups? Actually read them, make sure that everything's done well.
Practice restoring.
Practice restoring them. It's observed in the breach. But you, congratulations, awesome dude.
Unless it's not reliable.
This is cool. But it's potentially long after corruption. And again, with these big data systems, you don't get a chance to really, when it takes you hours to scan through stuff, you really want to keep from corrupting up front. So you want to adopt systems that keep you from corrupting. Yet they're still flexible and still evolve. And schemas are part of the answer to that. You need flexible environments to manage those schemas in a Clojure, right? Because things happened so long ago, you don't know the instances, the circumstances of corruption. So once again, having an immutable form lets you at least roll back to find the point in time so that you can stop the corruption, find out what happens. But if you had a total immutable store, entropy crushed all your history. It's gone. So this is just pan to schema. It's better to get an exception when the mistake is made before it corrupts the database. This is a truism of any kind of engineering. It's always cheaper to find the mistake earlier in the cycle. So types, while you're typing in the IDE, all of these things make the mistake finding and discovery process cheaper. And the most expensive place to find it is in production on a corrupted database that started corruption 3 years ago. It's the most expensive place you can imagine finding there. So if we can design systems to help minimize the human errors, we've probably done a great deal to minimize all of the potential error sources. Like schema is one of the things that helps. Saves enormous amounts of time. Why are they considered painful? It's considered hard, adding columns to a table, overly restricted, cannot do nested objects, require translation layers, ORM, requires more typing, development overhead. Well, are these issues of adding types, or are these issues from the relational datum systems? Okay, adding a column to a table. That's a characteristic of having broken your data up into tables. Okay, and needing to add certain things to every row in the table. Right. You're now adding structure to something that didn't have it when you originally wrote it. You're adding a new column. Gets back to the cache tag issue on Twitter data. The symbols do not exist. They should not be added to the data from tweets from 3 years ago. They should not be there. Schema is overly restricted. Well, why can't you do nested objects? Because of the calculus of relational databases, you can't do nested objects. So for example, the database I use, one of them, Couchbase, they have a new query language they're developing called NQL, N1QL, stands for non-first normal form query language. Okay, and it's about a query language that looks very much like SQL, but it lets you have embedded documents and has a dot notation, and you can go traversing down the data structures are the embedded documents. And so fundamentally, because they are all about these ACID documents, this makes a lot of sense for them. I'm sure, since this is so close to what it sounds like Datomic is, Datomic almost is certainly the exact same way. They're about embedded documents, and you can have embedded objects inside these documents. So this is restrictive because it doesn't match the real data models of the environments that we live in today. All right. Again, the relational model is trying to impose restrictions that were needed back on System 360 and data I/O channels, and where people worried about elevator sorts and all sorts of other constraints to make big transaction iron. Which, you know, this machine here doesn't even notice the workload. Doesn't even notice that it's spending time, right? This has got 2 1 gigahertz cores talking to flash RAM, and all the RAM and all of the disk is minuscule compared to what this machine does. So constraints from that System 360 era are still facing us. Is a problem. Okay. Because we don't have those constraints, so why are we imposing these restrictions on us?
Because we're dumb.
Because we haven't embraced the idea that one of the fundamental values of Moore's Law is that at some point in time, that which was expensive is now cheap and you should waste. Human time never got cheaper. In my job, for my personal career, is making more expensive crime, as is all of yours, I think.
I'm just a user.
Say again?
You get set in your own ways.
Okay. Require translation layers. So, for example, when I am on iOS, I have an environment called Core Data, which maps SQLite tables into an object graph. Okay. And if I do things wrong, it gets very expensive. Okay. In Core Data, I mean not Core Data, in Couchbase in Python, I get a dictionary. I go down the dictionary, it's a fast structure, everything's designed, there is no ORM, right? You know, there is an ORM for SQL in Python called SQL output. That is the one you use. I'm so glad that I don't use this. All right, I do a query, back come with 100 documents, I sort them going bang, 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 bang. I have my abstractions that index into the documents, everything is fast, it's tight. Yes, it's customized, but it's no more customized than actually indexing into any schema. Right. One thing that is actually quite interesting is that all of the systems that people are developing, like what Clojure has developed and what Couchbase has developed and what other people have developed, like the Mongo guys, they all do local storage on these devices with SQLite. But what they end up doing is storing everything as large blobs and just having a little bit of indexing around them to do the to pull things in and out. And in fact, in building the app you saw at the beginning, this is the 3rd generation of my iOS Twitter technologies. And I basically slowly moved more and more and more to that everything is kept as a JSON blob. And JSON parsing is incredibly fast on our native code machine. So it's just read it in, boom, comes out of the SQLite row cache like as fast. And so fundamentally, even the SQLite databases, you can start using them as just blob stores. And they're basically no different, actually, than the other databases. Because they are all blob stores also. They just don't happen to have some of the other right characteristics. Okay. So you don't necessarily need translation layers. Okay. And more typing, development overhead. Again, right? You're all here with Clojure. You like less typing. You like parentheses. Those are good things, right? Those are good things. But you're running on a JVM. You could be using Java. You're not. Okay. Same execution environment would perform the same, but you're not, because you've chosen a language that helps you manage your typing overhead. your development overhead, and how it manages type and mutability gives you advantages. So this isn't a problem of schema. This is a misattribution. This is a category error. This is that's not a category error. Actually, they're all category errors, but they're not about schemas. They're about the relational model. So that criticism is a category error. Does that make sense? As he said, none of these are fundamentally linked with function of a data unit.
Your syntax on that last slide's wrong. It should be parenthesis, function, data unit, parenthesis.
Nathan with these soils. Don't shoot the messenger, okay?
No updates for the Clojure group?
I actually did ask Nathan for the source of the foils, and he says, you don't need the source of the foils. So.
Hey, you wanted hecklers, right?
You bet I wanted hecklers. It makes it fun. The problems in the implementation of schemas, not schemas themselves. I blamed the relational model. Okay. The idea of schema tool is data is represented as maps. Okay, as hashes, as dictionaries with embedded information. Right. The atomic whole is the map, the dictionary. Okay. So this is what Nathan says. Right. And Nathan, when he was at Twitter, moved a huge amount of their infrastructure onto Cassandra, which is a column store. And in fact, almost every characteristic I'm told, or almost every property in a tweet has its own column. So he's living in this world that's totally normalized. But when it comes out to all of us and to internal structures, that all gets coalesced back into maps, in the hashes of dictionaries. Okay. They have a schema tool that is a library, helps them construct the schema function, concisely specifies required fields and types. It's a custom validation logic. I think this is the Apache project that I've forgotten the name of. But there is a whole set of tools to help them marshal things. They everything between systems inside Zookeeper. Not Zookeeper, no, that's just for
you said thrift in your comments.
Thrift. Okay, thrift.
Yeah,
The
that's
thrift environment. It's all about schema and marshal. Right. Everything inside Twitter is thrift enabled or thrift required to communicate. Right. They put nothing anywhere unless it goes through thrift. Okay. Because they carry the schema along with everything. It's an extremely important role for them. Okay. Build and support over time, fast and space efficient serialization, cross language. Okay. So this ends up being thrift. I bet it's not ideal, but I bet it's a lot better than depending upon the language specific schema tool that they can't take where they need to. All right, so now he's going to get provocative. I don't know, is that Jefferson? That might be Jefferson. Or maybe that's Thomas Paine. It's probably Paine, don't you think? Probably Paine. Who knows, they all have right. He claims the relational database will be a footnote in history. I think he said it to be provocative, of course. I don't think it's going to be a footnote in history. We will be running DB2 50 years from now. We were running 50 years ago, we're going to run it 50 years from now. All right. It'll be version 10 or version 30, but it'll still be DB2, second version. Same with Oracle. All of these things are going to be there because it is actually too hard to migrate your data forward. Okay. I learned this the first time when I was a graduate student actually undergraduate, and was working at the University of Texas Marine Science Institute in Galveston. The repository of the 7-bit data from the lunar systems, seismic systems. They didn't have the money to move those tapes forward. And so sometime in the mid to early 80s, we lost all the lunar seismic data that we spent billions of dollars to go to the moon to get, because we didn't move some data forward. And it was a weird 7-bit technology, and of course computers were really primitive in the late 60s and 70s. It was a really hard, painful engineering process. But we still lost this data we spent billions of dollars because moving literally a room full of tapes. I saw the room full of tapes, 7-track tapes. So data lasts a lot longer and we can't move it forward. So we better start embracing it in immutable form so that it's easier to move forward. Okay. So he thinks that it's going to be a footnote because of fundamental flaws in the approach to managing data. And I think if you guys agree with the basic immutability thesis that I've been pushing and he's been pushing, that you all have to agree that immutable relational data is, in our world of today, a bad idea. I don't think they had the choice back when the world was, 2 megabyte removable platters or drums. Right? When my dad was writing code, he was counting cycles, which was related to the rate at which that drum memory came around to get the next piece of his program, right? In those early systems, we're talking early 60s. Those flaws there, they were not flaws, they were requirements. We had no choice, but we don't have to keep embracing them. Mutability is the fundamental flaw. Okay, now, conflating storage of data with how it's queried. Okay. These were features because space was tight. Space isn't tight anymore. Let's not continue to make that mistake once we no longer have that requirement. Okay. So he says NewSQL is misguided. I don't understand the reference myself, but this point I am totally on board with, having watched Moore's Law's generations, 15 in my professional career. Okay, and disks have been increasing faster than Moore's Law for as long. Okay, so we have, these are cheap, bits are cheap. Rotating magnetic storage is ridiculously cheap. SSDs are even cheap. Okay, let's use that ability. Exploit what's free so you can really focus on doing the right thing with your expensive resources, i.e. us programmers who want to be even more expensive. I hate when people use the R word. Okay. It should be 4 letters. Whenever you're in an engineering discussion, someone says, let's do something right. They just did a 4-letter word, okay? Because what is right? Well, I think Nathan is actually going through a good discussion of what is right. When it's a discussion of properties of the data system that you want to have. Discussion of properties is very important. It has nothing to do with what's right. It's about engineering trade-offs. We just talked about, now that bits are cheap, let's stop making the trade-off that saves bits. And they are not the expensive part. The expensive part is when we screw up those bits. So let's stop worrying about saving the cheap stuff. Okay? I don't know if it has anything to do with being right. I do agree we should not inherit the complexities of the past. Okay. I know, use a NoSQL database. The quote he has it. If SQL's wrong and NoSQL isn't SQL, then NoSQL must be right. Yeah. So again, these are Nathan's spoils. NoSQL databases are generally not a step in the right direction. I'm not enough of a data expert, and NoSQL databases really.
I think the bottom line is that there's nothing wrong with the relational model. However, it has been misapplied, and that's creating problems.
Yeah, the relational model, if you accept all of the things that it does, is actually, it's the dominant data model of our day, right?
Foundational knowledge.
Right, and it works very well. How you use it is important. Most people use it poorly, all right?
Amen.
Like they choose the chalice poorly, okay. That said, it has mutability at its core.
But the relational model itself does not.
Yeah,
Relational
it's a set.
database systems do.
Right. And yes, I mean, relational model is just a set calculus.
Yes.
Right? That's all it is. Right. But updating systems, et cetera, is how it's used and how it's implemented. And one of the reasons COD developed it was to save space and to exploit and by using mutability. So I mean, it had
Implemented.
yes, in some sense.
Because COD didn't quite care about the implementation. He was a mathematician.
Agreed, and IBM had that problem, a lot of mathematicians. But they still had to ship systems, and the relational model got them 90% of the way to shipping systems, and the mutability got them the rest of it.
Oracle beat them to the punchline. It came down to it. Shipped the first DBMS, I think, about 6 months before.
So he does say some aspects are, but not the ones that get all the attention. And I'm not a NoSQL expert, I just do a few things. And some of the decisions that I have made were forced on me. So for example, when I'm looking at the tweet stream, it comes to me as one big JSON document. It actually is the path of least resistance. Leave it in as a JSON document.
I think there he's talking about the schema-lessness and that crap.
Okay.
Okay, to your point.
Okay.
Because that gets a lot of hype.
So he thinks that this is still a big problem. It's still based on mutability and not general purpose. And in fact, in my database, Couchbase, CouchDB, you can still mutate everything. Right? It's not necessarily a good thing. All right, so he wants to start from scratch. Okay, so now basically it's, okay, make some applications, cherry pie, okay, wants to start from scratch. Okay, what does the data system do? Retrieve data you previously stored. Put and get. Two big features, okay? Not really. Counterexamples, store location information on people, how many people live in a particular location, where does Sally live, what are the most populous locations? Okay, counterexample, store page view information, how many page views on September 2nd, how many unique visitors over time. Store transaction history for a bank account, show how much money does George have, how much money do people spend on housing. What is a data system? The query is a function on all data. Okay, so all of those things were examples of queries, not of the data system. Sometimes you retrieve what you stored. Oftentimes you do transformations, aggregations, etc. So it is kind of weird in my world of I pull in all of these tweets, and you would normally want to have the database do everything. But now when I've got data channels that run 200 to 300 megabytes a second, and once the disk gets there, I may as well get everything. I don't save anything by only getting little bits and pieces. In fact, it got more expensive. And I've got 8 cores sitting idle. Okay, I may as well just bring it all in and let me sort it out in the fast resources. And since I'm not going to write on top of that data, but append to it any changes, or it makes sense to actually do everything in a way. Because the way structures are. This gets back to the whole theory of disk is the new tape. Okay, so basically once you've indexed to where you want to be, get it all. Because moving that head or waiting for this thing to spin, you lose. You lose big. What I've been finding is bring it all in. You've got the bandwidth to do it. You don't save anything by not bringing it in. Even on small devices, you don't save anything by not bringing it in. In particular, you would think a device like this is very fast. Because it's all flash, it should be SSD. It isn't. It's designed for low power. And the other design point is about bringing big blocks that get given to video and audio playback hardware so the rest of the system goes to sleep. It's really bad at scattering. Okay, that's why the write access logging makes a huge difference because then they can just write these big 128K blocks, which is what SSDs like to write in, and they can do them all in big chunks. And basically SQL brings it all in, does all the sorting, writes big chunks back out, and everything gets faster because you're dealing with a different scale, right? So, you know, we moved from 512 byte sectors on our disk to 4K sectors. You know, now that we have SSDs, we really should be moving to 128K byte or 256K byte sectors. Because that's the natural grain size. One of my friends, Tristan Smolensky, likes to talk about mechanical sympathy. Our software should be sympathetic to the hardware it runs on. That's how it gets natural performance. Okay. So queries as pure functions take all data as input, most general formulation. Let me just accelerate through some of this. Total number of page views to a URL over a range of time. All right, so now he's written something. What language is this?
JavaScript.
That's JavaScript, yeah, okay. Or actually it's Java.
Nope, function. Let's say public, blah, 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 and Java.
Oh, yeah,
It's JavaScript.
okay. All right, so JavaScript.
And there's no semicolon.
Yeah, I mean, the auto semicolon addition in JavaScript just so screws you so many times. It's almost as bad as, you know, go to fail. That's such a great error name too. It's going to last forever, right? Implementation of the data is equal to the URL is the time, and then bump the counter. Okay. Too slow. All data is petabyte scale. On the fly computation, all data to query. Pre-computation, all data pre-computed view to query. An example query: bunch of page views come in. Pre-computed view, boom, 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 query. This is all setting up for MapReduce, right? Okay, pre-computation is all about doing the map and reduction. At least in the database I use, it actually pre-computes the maps and the reduction functions, and has a re-reduction function if you get above a certain grade size that they pre-compute. Okay. So this implies 2 steps in time. We talked earlier about how there was going to be difference in time, right? Well, this is going to happen at one time. You can't do anything to here until that pre-computed view is done. Steps in time. Data system, 2 problems to solve. How to compute views, how to compute queries from views. All right. Computing views, function that takes all data as input. Okay, this makes sense. Basically, doing the pre-computation, building your indices, they got to go over the whole data set. In any data system, right? Relational database, NoSQL database, anytime you actually have to create what is in essence an index, that is which is a piece of infrastructure that is going to be used to help you make the query. So let's use the royal term for index. You look confused, but you get the idea. You get the idea, right? Okay. That's done in a batch processing way. Framework for computing arbitrary functions on arbitrary data. Now, Nathan's also a big fan of Hadoop and distributed stuff because they use Hadoop a lot inside Twitter also. Though surprisingly enough, they also run one of the largest MySQL clusters on the planet, and every tweet still hits the MySQL cluster. It's so scary. That is the source. Every tweet is stored in MySQL right now. They have it in other things, but the infrastructure of their data systems and Rails and all the pieces that are around it, they're still, everything's going into MySQL. You want to talk about rigidity? Now, they got a lot of stuff around it protecting that MySQL cluster. Okay, and they, I'm surely now use it as basically a write-only store. Anyway, MapReduce is framework for computing arbitrary functions on arbitrary data. Okay. So many ways for doing that: cascading, scalding, cascading. This is calculating calculated independently on parallel. Because one of the characteristics is these have to be restricted to a single document. They can't reference other documents. Their job is to create a data structure that is used for you to query and to bring in the documents that you need, including the other documents. So one of the classic characteristics of the map reduces is that these have to depend on just the document you just read. There can't be any multiple document dependencies, multiple row dependencies, etc. You have to depend on. And this is clear, right? If you needed to depend on something that was on another cluster, you could die trying to pull all that stuff in, and you would not get any kind of scalability. Okay. So the fact is, we need to make sure our indices are independent.
Would you say that's related to the fact that they want to stream over the data against the disk?
Well, that is related to that, right? It's sort of, you can just basically take the data sort, just start reading it in, and then pass it into all the various functions, right? And then you can also have that be done in parallel across a bunch of horizontally scaled systems.
Right, all the shards.
All the shards can run in parallel. And that, but if they have to ever talk to another document, even one that came before, and certainly one that doesn't come after, you're screwed. Or, you know, systems like Couchbase, which have a hashing system in front of them that spread the load through the hashing system, you know, the document that comes after you may not be at all related to, in time, close to what you were, right? In fact, you know, I take the numbers and convert them into base 64 hashes, and base 64 hashes do not store the way the source numbers behind them do. I wish they did. There's a two variant that sorts properly, base 64 doesn't, and my database also uses Unicode ordering, which means I'm doubly screwed in trying to base 64 sort. Okay. All right. So once you have a batch view database, it's batch writable from has fast random reads, Elephant DB, Voldemort. Fundamentally, your index system lets you find the data quickly. You then want to read as much as possible. Exploit the bandwidth of these pipes is fast. It's tied to the rate at which, if you were in a write-only, append-only database, then everything is right there. At least the next 4K block is right there. And if your documents are small, you got it. No random writes required. Randomness kills you. Read, writes, kill you. Okay. All data functions batch view. Key thing is that this is simple, which means your human factors errors are going to be limited. And this is basically tied almost exclusively to your schema. Everything it's doing is based upon values in the schema. It is a very stiff piece. It can be very fast and be tuned, tweaked, and typed. Produce exactly the indexing that you need. And so when you're dealing with petabyte scale, that becomes important. Okay. Highly available, can be heavily optimized because of ring ones. Let's go back to this. Scalable and highly available. This gets back to CAP theorem. Okay. All right. Highly available because everything's immutable. Right. Availability became awesome. Right. And as soon as that view becomes visible, then everything is static and stuck, and it's highly available. So you have this temporal issue based upon how fast you can calculate the views. But it's not that you became inconsistent ever. You never became inconsistent. You became, is something available or not? That binary difference is huge, I believe. It makes your systems much more robust. It's not a question of consistency or availability. The data is available. As soon as it's written, it's available. Whether you can get it is a different question. And that's why NoSQL and these bigger data problems start to really undermine the ideas behind the CAP theorem. Because it's not as simple as the CAP theorem implies. And everybody likes to think pick two. No, it's not pick two. I can have consistency all the way and have things partitioned before I ever see them and have them available in any pragmatic sense. I just can't query them. That's a different task and a different concern, okay? And I don't think it's just a semantic difference. I think it's actually an operational design difference of how you think about your systems to make them robust. I actually think it is valuable that you can't actually query something from a separate system with a separate piece of code until it's actually been totally persisted and indexed properly. I actually think that's a data virtue of these kinds of models, that you can't get the data too soon. Be heavily optimized, tail right. This data is all normalized. This is him doing it all on single columns in Cassandra, but the function makes it easy for him to find each individual bit he may need to. Yeah, as I just said, it's not really denormalized, it's that the batch view knows what everything is. And you trade off the complexity of your query based upon the complexity of your batch view and the kind of indices that it creates. So we're done, right? Not quite. Key challenge is that that view computation takes time. Takes real time, hours. Right? I've seen this myself. I can fire up my laptop, have all 4 cores blowing and going with 5,500 tweets a second over to my server. And I can watch this much bigger server with 24 gig of RAM and 8 i7 cores, and it's just a big ass machine. Just get bogged down in this view computation. And so I can blow data out of the laptop faster than it can index. And that was really a surprise, since the i7 machine has 3.5 gigahertz versus these 2 gigahertz laptop. It was really quite a surprise. And I'm only sticking in about 7 megabytes a second. I'm not even filling up a 100 base T line. Okay. So this is really surprising how long these indexing can take. And so so it's not surprising that the inventor of Storm would say, oh, I have to do something about this performance issue. And of course, the amazing thing about Twitter themselves and their infrastructure, okay, is that they literally, when you write your tweet, it actually gets written in milliseconds. And then it gets turned around and reflected back out to all your followers, potentially in milliseconds. All right, they get 600 million tweets a day submitted to them, last numbers I heard, and they get probably 2 orders of magnitude larger number of tweets read every day. Okay, so not just 600, so 60 billion? 6 billion. It's a big number that gets read every day. And so they have this fast path and this slow path, and they run them in parallel. Okay. The reason they can do that is that they have an immutable base, that they know that when that tweet is written, whatever happens in the fast path, when the Oscar selfie happens and something crunches, and they haven't said whether anything crunched. It seemed to be remarkably robust. Almost certainly something crunched when Oscar selfie hit. This device, when Oscar selfie hit, this device was being sent between 50 and 70 tweets a second when Oscar selfie hit. That was astonishing that they sent me that many tweets, all of which were retweets. And they were only knocking out a couple of hundred every second. There was a ridiculously large number. And they were still feeding them to me. Their infrastructure was going. It was just astonishing to watch what the Oscar selfie did. Y'all know about the Oscar selfie, right?
Yeah.
Y'all don't know about the Oscar selfie? Okay. Y'all know about the Oscars, right? Just gotta check, okay. Okay. Oscars, big deal. Ellen DeGeneres was the host. Samsung did some product placement that you need to basically take a picture. So early on, she took a selfie of herself on stage. Satisfied the contract, okay? Later on, she was down, she whipped it out, she's down in down in the aisle, and she's sitting next to Bradley Cooper. Bradley Cooper is one of the people nominated. And then so she says, holds out him to do a selfie like Obama did with the Danish Prime Minister, etc. Then all of these A-list celebrities just jumped into the selfie, okay? And so it basically, it is the most retweeted tweet ever. The prior record was Obama 4 more years, okay? 700,000. Has over 3.5 million retweets. And it was tailing out. I was still getting retweets of this tweet, 4 days later. Okay, but it basically, it spiked. And during the Oscars, they exceeded the Obama tweet. All right, they went over 1 million tweets during the period of the Oscars. Because she basically said, retweet this when you see it. And it's like, let's break this record. She called out on the Oscars, 1 billion people were watching. And they blew through it. And it just crushed, it would have crushed old Twitter. New Twitter just kept going. All right? Because after all, it was just one tweet. Okay? And a bunch of people referencing this tweet. And almost all of that hit in the fast path. Though it was written once. Oh, and it was an image tweet, right? It had a picture too. So it was like, it was a real bandwidth pig. You're all welcome to come in. Okay. All right. Property is eventually consistent, okay, in the batch view, okay, without all the associated complexities, such as divergent values, vector clocks, all the other hoo-ha that distributed systems people know and hate, right? They all hate them. I mean, if you talk to Cassandra people, et cetera, they all talk about synchronizing across the rings, and Mongo people are just as painful. Part of the reason I chose Couchbase is they said, we handle that and you never get to see it, and they've actually been absolutely true. I don't ever have to see it. It seems to, I can scale the system up quite large horizontally, and you just punch a button and it rebalances it. It's very nice. They're more than worth the money if you ever care. Any of this stuff, okay. Pre-compute views for the last few hours of data. So he has this whole idea of real-time view. So enter storm, okay? Data stream processor routes them into NoSQL databases as application queues, application queries. So when you actually want to query and see what's in your stream, their query goes to both systems and pulls it all together to present to you a merged view that is your timeline. Okay. So pre-computation made all this fast. So the Lambda architecture is data comes in, there's an immutable store, and 2 paths, a speed path and a batch path. This is storm, this is the odd collection amalgam of trees. But if you sit and think about this for your data, if you have any kind of input data stream, if you're just doing transactions on a website, this maps into your exact model too, right? It's like, okay, they hit the buy, you definitely want to capture everything that was on that web page that was at all pertinent to that transaction. You want to catch it as, boom, we're done, right? We have a log view of that purchase. We can then reconstruct if we have to use a relational database from that, but we actually have everything that the user hit the button, and it turns out that it actually also matches those legal liabilities, right? Everything that came in, and you saved it, and you can always go back and roll it back to exactly that point. You can save what they actually bought. Without mutability, it's auditable. The credit card people come in and give you grief. You can just point to just what happened. We didn't change anything. Immutable architectures have some real virtues. Your lawyers will appreciate you. Okay? Now, this is the key thing, is that the real-time part is the most expensive, most error-prone thing you do, right? But it doesn't actually matter if you screw this up, because the data is actually safe. And so, yeah, you can drop down, and then you can fix it, and you can iterate and do whatever's needed, put in more scalable infrastructure, make your as complex structure as you need to deliver your load, but you know you're always safe. Okay, because this was a simple function, and this is a simple function.
In a few hours, this data is there.
Yes, and you haven't ever lost anything because it was persisted, it was consistent, available, and partitioned properly before you could ever look at it. And so the question then is, are the queries rational? Well, the queries are about, this is about building a fault-tolerant system in this scope of petabyte databases. So he's pointing out that this is where vector clocks and all that other stuff happen. Okay. This is complex, but the resource utilization is, it's only the last few hours. This is the part that didn't crush when the Oscar selfie happened. It's really impressive. One tweet went in and 3 million came out. And 3 million favorites and hundreds of, millions of views of that one tweet. Okay?
If you partition your database and you shard it large enough, those computations shouldn't even be a few hours worth of data. You could get it down to minutes. You have enough of those data branches and compute engines computing the views, right?
Yeah, they don't, because they've gone down this.
Your indices is the challenge.
Right, but that's what I'm saying. If you partition the data out, the indices that have to build over that small set of data can be built really fast because it's so small.
That is absolutely true. They've chosen to go down this path and to limit the amount of data that has to happen in real time. So most tweets are really happening here.
Right.
Most tweets are happening here. So this has to happen fast. A minute is too long. A tweet comes in and it actually can start going out, I think in under 50 milliseconds, 100 milliseconds.
Right, but you could optimize the other end so it didn't have to be a few hours.
What they found is once they did this, a few
Didn't
hours is
matter.
fine.
Okay.
Right. And once they made this robust and handled the complexity here, that this is what handles all of the minute by minute stuff, right? And this is where they want to have all the scale up, scale down, and all of the petabytes of memcache. They have petabytes of memcache running this whole stuff. It's ridiculous. Their infrastructure. I mean, unlike Facebook and Google, the Twitter guys tell us what they do. You can actually go find InfoQ videos of the Twitter engineers talking about all the things they've done. Right? It's amazing the kinds of stuff that they've got going. New Twitter of the last 3 years, is remarkably well engineered. It doesn't fall over, it doesn't do a whole bunch of things that it used to do. Okay. And I'm not going to take the cheap shot, it's not Rails anymore. No, there's still actually a big chunk of Rails in there. Okay. And it's not that Rails was bad, it was that it was a monolithic design. Right. And once they started cracking it up and putting this kind of stuff in there, the chunk of Rails is not the problem anymore. Hasn't been the problem for years. Okay.
It's a poor man's excuse to blame it on some technology.
Right. So CAP, real-time layer decides whether to guarantee consistency or availability. Okay, if it chooses consistency, queries are available, queries are consistent. If it chooses availability, queries are eventually consistent. So this is where CAP comes in, and it's all tied to the real-time layer. Because in the batch layer, you can't query anything until the views are finished. So once the views are finished, it's CAP. We're done. There is no pick 2 out of 3. You get all 3 once the views are finished. Right? And that's what I mean by temporal issues become important and whether you decide this. Okay? Eventual accuracy. Okay. back when I was at IBM, we were talking about video games and massively multiplayer online games. This is back in the phase when IBM was all about Second Life and all that sort of stuff. I started pushing this idea we call convergent simulation. And basically, your games like Second Life, like World of Warcraft, Star Wars, The Old Republic. What's important isn't that everybody on every system see the same thing, but that everybody converges to the same answer of who died in a relatively well-defined period of time. All right, and that's why one of the things the gamers care the most about is what is the latency. Okay. It's not so much that they can actually kill somebody because they have less latency, is that the game flows better when you have latency up to the referee, which is the server. But it's all about converting because they can't actually lock in. Like they're not going to slow because someone has slow latency. They're not going to reduce the gameplay quality for all the other people that just happen to be standing next to that person. Right. So fundamentally, they have this model of where things converge over time. So eventual accuracy is actually a very real design property. And you have to actually embrace it because you don't have control over latency. So this is, yeah, that's a very special case, real time, etc. But you know, when you start transacting money across the Atlantic, unknown latencies start happening, money transfers, things like that. This is probably a very real problem in any large-scale data system. Okay, eventual accuracy to compute an exact answer and the base layer approximate answer in the real time. Right? In Twitter's case, the approximate answer is almost always better. Right? It's almost always good enough, even crossing the record of retweets. Right? You know, because it was still being retweeted so fast, all that mattered was that it got over 1 million likes. Best of both world performance and accuracy. Okay, so here are the tools that you see in the Lambda architecture. All right. Kafka as, you know, this is their very first thing, right? Kafka is just this basic log anything. So basically, clearly all the tweets get logged. That's the very first step. All right, that's, y'all know Kafka? Well, it's basically a very complex logging system that can arbitrarily log any kind of data, but it really is append only, and it's all about speed. Okay. No indexing, etc. You can only really go in and out in order, right? But tweets are safe, submissions are safe immediately, even before they get up here. They're safe. All data, he does Hadoop, okay, Storm or the pre-computed view, and then the queries are merged through Storm, okay, through Storm infrastructure. All right. And he's doing all of the fancy stuff down here with Cassandra Wrap and HBase, okay? But this is all pure Hadoop up here. He doesn't really show that MySQL's in there. It just is a tanker to his life, I think, our thought. All right.
So the only thing this thing doesn't really cover is legal requirements for expunging data.
Right.
So
Once you write it, you can't mutate it.
You've got no way to get it out.
Yeah, it does.
You can use it on any system that actually is to support.
Well,
Unless somebody's got something.
Well,
It's almost like it's usually around retention, not around purging.
the what?
The legal requirements are usually around retention, not around purging. So let's say you have to keep at least 5 years of data, and then your legal department will say once it's over in 5 years, once it's over in 5 years, get rid of it, because they don't want to have to go through the trouble of e-discovery, anything that's beyond the legal requirement.
True, unless you're doing things like
Wage garnishment.
or whenever you have to anything where you have to, they say that information needs to be gone and retrievable.
So,
It's hard to argue about immutability and database implementation with your terms.
Yeah.
well, you're correct. This doesn't actually preclude you building batch files that are very carefully constructed that go in and null out data. It doesn't actually preclude that at all. What it says is deletion is a rare event that is very carefully considered, and it's certainly not in your real-time path. And it's certainly something that affects your batch path in a well-defined, simple way. Right? So deletion happens. Right? If you read Nathan's book, he talks about deletion. Okay. But from your architecture perspective, deletion should be a rare event. Mutation should be a rare event. Deletion is the ultimate mutation. Okay. But for example, deletion doesn't actually have to be deletion. It can be just overriding and including the data so that you don't have to touch anything else around it. And you don't have to compact. You can just go, we're going to go put random bits in all those bytes and we're done. Right? And so very carefully control what goes.
Usually almost all those scenarios you're naming too are temporal. So they're so old, a lot of that data is going to be offline in the secondary or tertiary storage. Right. So none of the performance things of this are going to matter. You can run it in a third system and let it do those things. So I think that's a benefit.
Right. I mean,
you're never going to impact the mainline system.
Certainly don't let this rare case
assume
abuse the common case. Okay.
I don't know what the solution was, but I remember Rich Hickey talking about this with AUSOME, and they came up with some solution. I don't know what it is. Maybe somebody.
You maintain record of delete, so you can tell who deleted.
Yeah, but I don't know like the technical details of what it is. But they've thought about it, and the people seem to be happy with it. I don't know if maybe somebody can give them a talk about that sometime.
I don't know if they've actually talked about how they did it.
Oh man, I would assume so, but I don't want to. Anyways, the point is, even in something like Datomic, this issue has come up, and
well, it's a very real data management system, right? You don't want to have to argue with the judge and say, well, that's immutable architecture, that's the way it is. It is in the code, it cannot be changed. Judge doesn't buy it, but in fact, it is true when you say that. It's in the code. He doesn't understand. Doesn't mean.
The key there is that not part of the natural state of the system. It is a feature of the system, not the natural state of the system to be.
Right. And if you know you need to do that, just like this is a design and architected, you can architect for that. Yeah.
But I think that I hope you agree with the motivations that Nathan has been pushing here. I agree with him that when you're dealing with these large systems, right? I have 5 million tweets a day come into my house, 12 gigabytes of data every day come into my house to help me work on this porn filter. All right. To me, that's an astonishing fact that this comes into my house every day.
Do you have any cops coming by to check on your porn? I mean, because if you got all that porn coming in, what do you say? Hold on, let me show you my filter.
Let me show you my immutable data store.
That's right.
No, that's just the tweet store.
No, I understood. It was right for the time.
Yes, it was right for the time. Right. I'll remember to write you an email to somebody. Okay.
There you go.
Okay.
Chief Ossovich.
But I look at this and I see a lot of basic sense. And so I believe that you can actually adopt it incrementally, and that as you move more and more to less mutable storage, your systems get stronger and more robust. Nathan probably would tell me I'm an idiot, okay? But I can tell you that I've seen my world get better just by having gone through the reasoning process about the data systems here. That I can now go into discussions with clients and other people, and we can have some very clear discussions on the trade-offs and why someone wants to use a different style of data storage mechanisms, or how to rework their relational system such that you can get better performance in the scale of what you're dealing with. So I find this a compelling stuff. He's got a complete book called Big Data from Manning Publications.
It's very good, by the way.
Which you can go through. The key thing is, building, for the future, he says the key thing is building abstraction over batch in real time. Okay. and he wants to build more data structure implementations for batch and real-time views. That is what hasn't really emerged from the NoSQL movement. NoSQL movement has been, as you saw in that implementations chart, is a bunch of little point products. No one has actually done this whole thing. Learn more from the book. Questions? Okay. So thank you for allowing me to share that with you. I hope it was instructive. I'm happy to answer questions. So I think you all asked me during the talk.
I have one. I mean, some of the architecture things remind me of some of the very early systems where to your point, you're talking about the rotational speed of the drum and stuff, because they used to serialize the data on those things and make it so that an access would be slide down to this position and then dropped ahead. And it was because all the data was exactly the same block size, same record depth, everything, right?
Yes.
And you had padding, right? And they did streaming stuff through the hardware and all that. So other than the map reduce part, what is the other major difference than some of that early stuff before the ISAM and the hierarchical systems that this really adds to that? Because that was streaming. They were just streaming it to the disk.
Right.
And then they went to RAM as well. What other than map reduce, what's the real big deal? Or is it Storm, or what is it?
Well, for them, you know, for Nathan Company is the fact that he has a real-time path and a static batch path. Okay. Now, you know, I've talked to a couple of people in scientific computing, and they look at us document database guys with our JSON, hoo-ha, et cetera, and they go like, how can you do anything? And I basically make the point is, yes, JSON doesn't have a nice numeric data type. And yes, it is wasteful. But frankly, once I've indexed it, I get to it as fast as anything you can get to. Right? Yes, they're more compact. They can actually get things faster, but they pay the price in a stiff schema. Okay.
The beauty of it is that here, if something, you know, if there's an error, because you have all the source data in that all data section, you can always correct the error because you can rerun all those transformations. It's just going to take a long time, but you can rerun them. And
Yeah, I got that, but the performance side is, because the performance side is one of the places where Andrew talked about as being a huge deal, and the reason it's a huge deal is it handles Twitter,
well,
right? But to me, relative performance, going back to those older systems, isn't really that much. For example, I can give you a concrete system I worked on, called detail records for cell phones. You're driving around and your cell phone's sending out data to multiple towers at the same time.
Which organization might that be?
NSA.
It doesn't matter. Anyway, they come back randomly.
No such agency.
Right? So we couldn't insert them into a SQL data store, even with 16 or 32 CPUs and parallel disks. It just couldn't keep up, any at the time. I mean, so we had to create our own equivalent streaming storage system that would write to local file systems and then have a separate process to do all this, right? So the consistency thing, I'm all bought in. It seems to me like that secondary store is just standard persistence, and the real deal that you're applying
What's the
is
secondary store. This stuff?
no, the green thing, because the stream is the primary to me, right?
No.
Secondary
No,
is
not quite. I mean, the way I understand it is that the all data is everything is going there. However, the last like sum window is going into this pre-computed through Storm into this pre-computed real-time view, and that is not necessarily as thorough of a computation as it can be,
right,
but it
it's
is
doing real time.
handling the volume of data that it can with the computational resources that it has. And then even if there's some error here on this one, it will eventually get all corrected.
Right, because it goes through the green side.
Yeah, it goes to the green side eventually.
Right, but the thing that still comes out to me is that you've got the real-time input and you parallelize the problem. And in your two paths, I mean, you could in-path it, but you could have 5 real-time sides and 5 or 10 or 15 slower time sides, right, just to get throughput. But it really turns into a massively parallel architecture solution, not necessarily intrinsically a data solution, right?
Right.
Because one of the things you get out of massively parallel architectures is simplifying the chunk of code you need to compute because you partition the data. Or if I flip this, it also reminds me of how you used to do merge sort. You partition the data, you sort it, and then you bring it all back into one. Same kind of deal, right? So am I missing something completely?
You're not missing anything.
Okay.
Right. What you're missing, and it's not even missing, is that the scale of this stuff is so huge, right? The fact is that once data hits the disk, it never leaves, it never moves again, right? You know, this may as well be optical storage as far as it's concerned.
Right.
Right. So that is a, you know, a huge constraint. Like I said, I have 12 gigabytes a day that come in, and you know, it hits my disk and it does not move again.
Yeah, that was like, that's why I give the call detail record saying for cell phones is similar. Okay, I just want to make sure because I read that book sitting at Barnes and Noble one day.
It isn't a deep book.
And it was good, but I was thinking maybe I missed something along the way, so thank you.
You didn't, you just experienced it. Okay.
So we should take this
It's
downstairs so that they can.
Okay.
Sorry for keeping you late.
One more thing. For anybody who's parked in the garage,